Hi everyone, I'm G. Mohan Raj. I'm going to explain about CNC milling machine in this video. Let's start. CNC, Computer Numerical Control. CNC stands for Computer Numerical Control, and these machines play an important role in the manufacturing industry. The complex machines are controlled by computer and provide a next level of efficiency, accuracy, and consistency that would be impossible to achieve through a manual process. In modern CNC system, end-to-end component design is highly automated using computer-aided and computer-aided manufacturing programs. History of CNC. In 1955, as Air Force defined a new to develop a machine tool capable of machine complex and close tolerance air parts. In 1959, MIT is a contractor and built the machine for the project. MIT announced automatic programmed tools programming language. In 1960, direct numerical control. This eliminates paper tape and allows programs to send files directly to machine tools. In 1980s, CNC machine is introduced Unix and PC-based systems. In 1997, PC Windows operating system in attached to CNC. How CNC machines works. CNC machines are controlled by G codes and M codes. These are number values and coordinates. Each number of code is assigned to particular operation. The CNC machine process starts with design the parts in CAD software. The 3D model determines the necessary dimension and properties of final part. Nowadays, if design a product and put the software, it automatically generates the required G code and M codes, typically in manual to CAD by machine operators. G code and M codes are automatically generated by the computer software. Programming key letters. O means program number. N means sequence number. G, proprietary function. X, x-axis destination. Y, y-axis destination. Z, z-axis destination. R means radius destination. F means feed rate of destination. S means spindle speed destination. H, tool length offset destination. D, tool radius offset. T, tool destination. M, miscellaneous function. G codes. G codes refers to a language that used to tell a machine how to move basically. It is the geometrical code. G code determines the movement and the speed of the cutting heads. Important G codes. G00, rapid transfers. G01, linear interpolation. G02, circular interpolation. G03, circular interpolation CCW. G20 or G70, inch units. G8, cancel canned cycles. G18, drilling cycle. G82, counter boring cycle. G83, deep hole drilling cycle. G90, absolute positioning. G91, incremental positioning. M codes. The M codes, on the other hand, gives all the info that G code overlooks. That's why it is called either machine code or miscellaneous code. The important M codes. M00, program staff. M01, optional program staff. M02, program end. M03, spindle on clockwise. M04, spindle on counterclockwise. M05, spindle stop. M06, tool change. M08, coolant on. M09, coolant off. M10, clamps on. M11, clamps off. M30, program stop, restart to start. Cutting fluid or coolant. Cutting fluids are to cool the workpiece at high cutting speeds and improving the tool life and also improving surface finish, flushing away chips from the cutting zone, caution protection of the machined surface. Cutting fluids are made from petroleum distillates animal fats, plant oils, water and air or other raw ingredients depending on material the cutting fluid is selected. Types of CNC machines: turning centers and milling centers, vertical milling centers, horizontal milling centers, and drilling machines, EDM machines, laser cutting machines. Let's see VMC, vertical milling machine. VMC typically stands for vertical milling center, which also a CNC. In CNC machine workpiece is stable and the tool rotates. VMC machines are controlled by a CNC. As mentioned, the cutting head in this milling machine is vertical and is typical and particular type of milling machine where the spindle runs in a vertical axis known as the Z axis. They are typically enclosed and most often used for cutting metal. Operation held on VMC. Most of the operations of VMC is metal removes with a revolving cutting tool called a milling cutter. With various attachments, milling machines can be used for boring, slatting, circular milling, dividing, and drilling. This machine can also used for cutting keyways, racks and gears, for floating taps and reamers. Tools used in VMC. The most common types of milling cutters are end mill, face mill, ball cutter, slab mill, slide and face cutter, involute gear cutter, fly cutter, hollow mill, shell mill, roughing end mill, pivotile cutter, wood rough cutter. Uses of VMC. VMC can be utilized for not only cutting, but also drilling, graving, engraving, tapping, countersinking, chamfering, and many other applications. Because of their versatility and relatively low cost, they are extremely popular machines that are found in shops all over the world. Advantages of VMC: high productivity. The open visibility of the vertical milling machines centers make it much easier for larger part manufacturing. They are the perfect choice for easier, less complex jobs that require lower quantities. For quick milling jobs, these machines are the perfect solution. Disadvantages of VMC. The CNC milling machine and setup are more expensive than manual instruments. The workers to operate milling machines need proper training. It takes a time period. It takes period of time for design and programming, not so cost effective for small amount of products. Then thank you. Thank you for your kind cooperation.